Hey, morning, Lila.
Hi.
How you doing?
Good, you?
Questions that you have on the PSAT practice?
I don't really know which ones I have questions on. Have you graded them yet to see which ones I've gotten wrong?
Good question. Okay, let me see if I have answers somewhere. Just a minute. It's gonna take me a sec. Hey, Nisha, how you doing? Let's see.
I'm good.
I don't know if I have all the answers written down. I did it weird. Nisha, do you happen to have the answers written down? You don't, do you? We can figure them out pretty quickly here. I know a lot of them. So like this number 2, I believe was, let's see, 4 times 2 to the x. So it would be,
I have the answers pulled up.
oh, you do? So what's number 1?
D.
And then 2?
Yeah, it's 16. Number 1
Okay, and number 2?
is D.
Okay.
Also.
Number 3?
B.
4?
C.
5?
D.
6 was 0, I see, I think. 7?
D.
And 8?
D also.
9?
D.
1/3? Yeah, there was a lot of D's. Let's see, 10?
It's D too. I don't know. Okay. Yeah. Then
11?
B.
B?
Yeah.
And 12?
D.
Of course. And 13?
B.
And 14?
C.
And 15.
A.
Thanks. Okay, Nisha, do you have a question about one of them? We can go over like how to do some of these.
Number 2.
Okay, let's look at number 2. So let's go to sorry, I'm gonna take a picture of it and then I can write on it bigger. Okay, so on this one, you can eliminate a couple right away if you know a little bit about exponentials. So exponentials, the way exponentials work, like, so the basic formula is y equals like b times a to the x. Like that's the basic form. Think of this guy as the y-intercept. And think of this as how much you're growing or decaying. And so, so right away, you can see like when a is bigger than 1, it's growing. When a is smaller than 1, it's decaying. So a is 2, or a is 2 there, which means it's definitely growing. Does that make sense?
Yes.
Like we had some graphs where it was like 1/2 to the x, if you remember those, and that graph is decay. It kind of goes like that. So when that number is a fraction, like really small, it would look like a or b. It's not a or b because a is definitely a number bigger than 1. So right away, you know it's either C or D. And the y-intercepts look to be honestly pretty similar. It's hard to tell where they cross, but I can't really tell if they both might cross at 4. It's just too hard to tell there. So let's pick a value that's easier to check. So like plug in a value like x equals 2. So if you plug in x equals 2 here, this would be 4 times 2 to the second power, or 4 times 4, which is 16. So when x is 2, the y value should be 16. So x is 2, the y value should be right in there somewhere. X is 2, 16. Like that one looks right. Does it make sense how you could just test a value to be sure? Because I could tell right away at 2, they had 2 different values there. So I would just test a value to be sure there.
Okay.
That's how I would do that question. Other questions, really anyone can ask.
Number 15.
Okay, let's look at 15. Okay, let me take a picture of that. Oops. Okay, so in 15, so the graph of that one intersects the line at 1p. Okay, so one way is to do this algebraically. So let's start that way, and then I'll show you how to use your calculator to do this, because it might be a little easier on your calculator. So you could just plug in a value. So that's our x value, that's our y value, right? So if I plug in x is 1 right here, I would get y equals 1 squared minus 9, which is 1 minus 9 is negative 8. So one of the points is 1 comma negative 8. If I plug in x is 5, I can figure out my y value. So if I plug in x is 5, y equals 5 squared minus 9, which is 25 minus 9, which is 16. So there's another point, 5 comma 16. So now I really have my question, which is, what's the slope of the line when I have these 2 points? And so if you find the slope formula is m equals, y2 minus y1 over x2 minus x1. And so this would be 16 minus negative 8 over 5 minus 1, which is like 16 plus 8, which is what, 24 over 4, which is 6. And so the slope is 6. You can, if you have access to your calculator, because you can use a calculator on this calculator portion of the test. And so we could just graph, go to a graph page, and this would probably be easier. Graph x squared minus 9. Do like the trace command, so menu 5.1 is trace. Type in 1 and press enter. Oops. Type in 1 and press enter. You get 1 negative 8. Type in 5 and press enter. And you get 5 comma 16. We might need to change our scale here so I can see this graph. I'm going to change that to negative 20 or something. So you can see those 2 points. You can see they definitely have a positive slope. Like at that point, we could cross out these 2 answers, because if you connected those 2 lines, it's going to have a positive slope. This is actually something you can do. I don't think I would probably recommend this, but you can actually go to geometry and draw a line in there. So I'm going to draw a line from that point to that point. So you can actually draw it in there. And if you want to right click, so on your keyboard, just right click and go coordinate or measurement. Oh, it won't do measurement. What? I thought it might do coordinates and equation. Let me see. Coordinates and equation. So it gives you the equation, the line, if you right click on it. Right click on a handheld is control menu, by the way. And so 6x, so the slope is 6, the y-intercept's negative 14 of that line. Or you can just do it algebraically by hand by doing that and then figure out the slope formula. Other questions?
For number 9,
Sure.
I plugged in 0 and I thought that was correct.
Okay, so let's try that if you plug in 0. So if you plug in 0, you get x squared plus 0x plus 16 equals 0, right?
Wait, sorry, number 9.
Oh, sorry, 9. Okay, so plug it in 0. So if you plug in 0 for k, right?
Yes.
Okay, So that would be 1/3 times 0 minus k, equals, x minus 0, because we're doing 0 for k, and then it would be equals 0 times x. So we get, this would be 1/3 x on the left, equals 0 times x is 0. And so 1/3 x equals 0, so x, if you multiply by 3, x equals 0. That's an actual solution. Does it make sense when I say that's a solution?
Yes.
And
What I did was I also plugged in a value for x, and then it like didn't match up, so I thought that meant that it was no solution.
so there's different ways of thinking about this problem. So I think to check if something's no solution, you really can't just choose a value for x like you're solving for x. Does that kind of make sense?
Okay.
So I'll show you a couple of ways we could have done this problem. First, I'll show you the kind of the shortcut way, which I really like, and then we'll maybe try a longer way of doing it. I did it the long way the first time. I did not see the shortcut at all. But after I thought about it some more, I did see the shortcut. So when you have like a graph here, if I had a line here, let's pretend this is like a line. Does that kind of make sense? Like it has a slope of 1/3. I'm not sure what the k value is. It looks maybe something roughly like that. Does that kind of make sense?
Yes.
Like I'm graphing the left-hand side. If an equation has no solution and I wanted to graph the right-hand side, how would that line look on the graph? Like what would the line look like? Would it kind of cross like this? Would
It
it be
wouldn't
like,
cross.
it wouldn't cross, so it'd be a parallel line. Do you agree with that?
Yes.
So the slope of the original line here is definitely 1/3. I can tell that because it's like 1/3 x there. And so the slope of this new line would also have to be 1/3. So k has to be 1/3 and I'm done. That's the fast way of doing it. It
Okay.
actually kind of works. But the slow way of doing it is actually cool algebra, if you want to see it. So it would be this is the way I did it first, 1/3 x minus 1/3 k, just distributed there, equals kx. So I want to solve for x. So what I did is I tried to get x on the same side. So I subtracted kx, and I added 1/3 to both sides, if that makes sense. I'm going to add 1/3 to both sides. So I get 1/3 x minus kx, 1/3 x minus kx equals 1/3. And now I'm going to factor out the x here. So I get 1/3 minus k times x. Did you follow that step? I took out a GCF.
I did not, but I understand that.
So I took out a GCF of both terms. I'm trying to get x all alone. That's really the only way to do it, to get x on the same side and then factor out the x to get x all alone. Now I can just divide by this 1/3 minus k and divide by 1/3 minus k. And I get x equals 1/3 over 1/3 minus k. So I could plug in any value for x, for k there, and have a solution except for one value. What would make the denominator equal to 0 there? Because I can't divide by 0.
1/3.
So if I plugged in 1/3 there, that would make the denominator 0. So that's the only value that would make this equation undefined. I guess. Does that kind of make sense?
Yes, thank you.
Other questions? Because if you can do these questions, you know, you're going to do just fine in that quiz. They're very similar.
Number 6.
Okay. So this one, there's a bunch of different ways to do it. One way is to actually just graph it. So one way is to go to graph, type in, x minus 5 times x plus 5, and graph it. And where does it reach its minimum value? You can, I'm just going to change that value like -25 or something. It's still not quite low enough. You can kind of look at it. So it looks like it's right down there. To find that negative value, what I always do is just use trace, menu 5-1. And you can see it says the y-intercept, which is also the minimum, is 0, -25. And so for what value of x, and that's the key there. So the minimum is 0, -25. That's the minimum point. But it talks about the x value. Well, the x value is 0. Very tempting answer there with a being -25, because a lot of times, like a lot of students might just read minimum value. Well, minimum value is -25, but what is the x value that the function reaches the minimum value, and the x value would be 0.
Oh, x value on a graph. Okay,
Yes.
that makes sense.
And like some students do it very graphically, so they actually just like saw the two, like the y-intercept or the x-intercept were, I think they were like +5 and -5 here. And so the x value of the middle of that graph is going to be 0, if that kind of makes sense. Like it's right in between points. So some students didn't even actually have to use the calculator graph, and you could just kind of think it through. Well, what's the middle of that graph? That x value would be the middle of the average of those two numbers. If you average 5 and -5, you get 0.
Gotcha.
It's
Thank
a
you.
different way of thinking. But
Thank
I
you.
thought the tricky part was that, because a lot of students might have thought -25. I would imagine that would be the common wrong answer there. Other questions?
Could you do number 10?
Sure. So one way of doing this, which I may or may not have ever shown you, but for standardized tests, I'd like you to know this. So you can actually do this in your calculator if you want, and let the calculator do all the work for you. So one way of doing that is to go to menu algebra, and then there's solve a system there. And so if you just say, okay, you type in the first one as, x over 2 plus 2y equals 14. And then x minus y divided by 2 equals 1. And it gives you the answer of 4, 6. So what is x divided by 2? Well, x is 4, so 4 divided by 2 is 2. That'd be a really fast way of doing it. The way to do it by hand, what I would do if I were you, if you were doing this by hand, which would be fine to do, I like to get rid of those fractions. Do you see those denominators of 2 there?
Yes.
So when you do that, you get x plus 4y equals 28. And this would be, I guess, 2x minus y equals 2. So now you have a regular old system. You still might have to make some adjustments to this. In other words, like, which way do you like better for solving, elimination or substitution?
Elimination.
Okay. So like you could either, let's just multiply this one by 4 down here. This makes sense. Because you can eliminate y's that way. And so if you do that, you have 1x plus 8x is 9x. The y's go away. 28 plus 4 times 2 is 8 is 36. Divide by 9, you get x equals 4. And 4 divided by 2 is 2.
Awesome,
make sense?
thank you.
So that'd be the easiest thing. Like those fractions really become troublesome when they're there. So it's just easiest probably to get rid of them first.
Okay.
For most students. Other questions?
Number 8.
Sure. Okay, so this one. So you've got so you really there's a lot of different ways of doing this. Let me talk about a couple different ways of doing this. Okay, one way is just to take it kind of like that work backwards strategy I talked about in the ACT strategies or SAT strategies. It would be just like plug in the answers and see if they work. Like, let's just take this answer of -4 and test it. So if we plug in -4, we get x squared minus 4x plus 16 equals 0. And so if we try to factor that to see what the solutions are, we get x and x. Factors of 16 that add up to 4. 4 and 4 doesn't work. 8 and 2 doesn't really work. 16 and 1 doesn't really work. I can't really factor that. So right away, I know -4 is not a solution. Because it only has one solution. Like that one doesn't even, it has like, it can't be factored. And I guess we could find out what its solution is, but it doesn't seem to be the right answer here. Let's try -8 and see if that works. And just because I like to factor first, it's easier to do. So if we put -8x plus 16, does that factor? So if we try to factor that, that should be easier, I think. X and x. 4 and 4 add up to 8, and -4 and -4 add up to -8. And I think that works. Notice the factors are the same. So x equals 4 in both cases. It's the same solution. It has only one solution. So x equals 4. So -8 definitely works. The only thing I really need to test is, does +8 work? So if you plugged in +8, you would get, again, can you factor that? And it looks like you can. X and x, 4 and 4, plus and plus. In that case, the solution is x equals -4, but it's the same solution twice. So 8 and -8 works, so it's got to be D. Graphically, you can use your calculator. So if it's easier for you to graph these things, you could take these answers, x squared plus 8x plus 16. And if you can tell, like you could trace there if you want to, menu 5-1, and trace over to the graph. But it looks like it only crosses the x-axis at one spot right there. A minimum on the graph. It's also an x-intercept of the graph. So when the graph has that look to it, it's definitely going to have only one solution. If you change that to minus 8x, oops, also only has one solution. It looks like it barely touches the graph at +4 there. So graphically is another way of looking at that. There might be another way of solving, but just taking the answers and plugging them in. There's only a couple answers really we had to test. So I think that would probably be a pretty good way of doing that problem.
But why doesn't B work? Because it's like it's -8 and there's only one solution. But like if you have -8
The
and
-8 does work, but it says only -8. But actually
Right.
+8 works also.
So why do they both work? Or why do they have to both work? Because it's only one solution. I'm confused.
So when B equals -8, the solution is 4. When B equals +8, the solution is -4. In both cases, there is only one solution. So B isn't so much wrong as it's not the best right answer.
Okay.
Like D is better because it has every possible case where there's one solution.
Okay.
That kind of makes sense?
Yes, thank you.
It's like a logic question. Like lots of times on an AP test, there's like, yeah, B is like, it's kind of correct. Like that's true, but it says only, and actually there's an additional answer that you missed if you said B. So that's why you always check, like you go, well, there's 2 answers here. Oh, I better check 8 just to see if that one works or not. When you see that there's a repeat of an answer there. Other questions?
Can you do number 5?
Sure.
Because I think I guessed on it because I got it right, but I don't know how to do it.
Okay, so let's do it in a couple ways. So one way you could graph it, and remember how to do a relation. I don't know if we did that a lot with the project. If you hit delete here, you can choose number 6 relation, and now I can type that in just like it is. Y. I think you hit the control equals to get the less than or equal to. x, and then also graph y, control equals less or equal to negative x. And so the solution region is the double shaded region. So the purple region's kind of both of those sections, the kind of like reddish type thing is both those. So do you see this triangle down here? That's the solution region. So
Okay.
any point that's in that solution region would be a solution for this problem. Oops. Sorry, I was trying to bring it to there. Or so like when you look at these solutions, 1, 0 is like right over here. It's like in the purple region. Negative 1, 0 is kind of in that reddish region. 0, 1's in the white region there. And 0, negative 1 is in that lower triangle. That's the correct answer because it's in the solution region. Now, you don't have to do it that way. Another way of doing it, and this is a pretty valid way of doing it, is literally just plug in the x and y values here and see
Yeah,
if
that's
they
what
work.
I did. But I just got confused because, like, in the equation, it has, like, for the top one, less than or equal to x, but 0 isn't, I mean, but negative 1 isn't equal to 0. So I got confused on that.
Okay, so let's see. So when I plug this in, I get negative 1 is smaller than or equal to 0. That looks to be true because it doesn't say it's equal to 0. It says less than or smaller than or equal to 0. When you look at a number line,
Okay.
like 0's here, negative 1's here, it is smaller than 0, so that's
Mhm.
true. And then this one, if you plug in negative y is less or equal to negative 0, I guess, right? Which is really 0. And that's still true. So because negative 1 is less than 0. So it's when it says less than or equal to, that means smaller than or equal to. So it wasn't equal to, but it was smaller. So those are both true. So literally that's almost just as fast. I mean, you could graph it, but literally plugging in the points is definitely another way to go. That's not a bad way to go at all there.
Okay.
Other questions?
Seven.
Sure. So I thought 7 was pretty tough, actually, because we haven't done a ton of this kind of stuff. Right away, you notice, like if you're drawing like a line of best fit, it might look, I don't know, roughly like that. I'm just kind of like sketching a line in there. The slope, I can't really tell right away. It's definitely positive, but all these slopes are positive. The slope is either, if you look at it, the slope is either 1.6 or 16. So I've really got to figure out if the slope is right first. So I'm going to try to figure out the slope. So the way I did this is I just took, really these 2 points are pretty, like if I just took those 2 points, does that make sense? That'd be pretty close to the line. So I just took those 2 points just to have like nice points there. And so I did, this point was what, 6.8 comma, I think it was like 122 or something. And this point looks to be 5.2 comma 95. So if you just find the slope formula between those 2 points, so that would be 122 minus 95 over 6.8 minus 5.2. So you want to get your calculator out. And I guess you do 122 minus 9.95, I guess, over 6.8 minus 5.2 is 16 point something. So right away, I know it's not one of these. Does that make sense? It's got to be one of these two because of the slope is 16-ish. Like it looks like it's about 16. Now at this point, you've got to figure out the y-intercept. It's kind of hard to do. You could just kind of use a point. There's a bunch of ways to do it at this point. So you could like kind of use slope-intercept form, like y equals mx plus b. Pick a point, like say this point right here, and we could plug in this slope of 16. We think the slope is 16 according to this. So you could say 95, which is the y value, equals 16 times the x value, which is 5.2, plus b. And so if we do that in our calculator, we get 16 times 5.2, 83.2. So 95 equals 83.2 plus b. If I subtract that from both sides, I get b equals, I guess it'd be 95 minus, whoops, 95 minus that number, 11.8. I didn't get exactly the right answer, but I got a positive answer, and that's close enough to that one, so I would probably guess D at that point. So that's just like, that's something we haven't done that. I think we did that earlier in the year, but it's like you could use the point slope formula or the slope intercept formula and just, figure out, plug in as long as you have a point and a slope, you can figure out the y-intercept of a graph by just plugging in your x and y. And so I just chose that point. You could have chosen just about any of those points, probably got it right.
Mm-hmm. Thank you.
Any other questions? Did y'all graph number 14? That'd be a good one to graph. I didn't understand 14 until I graphed it. I thought it was a really tough problem. So if you graph like 2 to the power of x, and then also graph 2x plus 2, 2x plus 2. And I'm just going to kind of recenter that a little bit here so you can see a little bit of that graph. So it says for x greater than 0. So all we care about is we really don't care when x is negative. So I'm hiding that part of the graph here. And I don't think I need all the way to 10. I think 6 would be fine here. The graph kind of has this kind of a look to it here. So for all x, is it true that 2 to the x is always less than 2x plus 2? Well, actually, it looks like 2 to the x is, for this first part of the graph, is less than. But then after a while, it looks like if I go to menu 5.1 here, or let me go to geometry. Remember we did points and lines and finding the intersection point? So if I click on the two graphs, it looks like it crosses here. Until the x value is 3, 2 to the x looks lower, smaller. So until x is 3, but not for all x. So that's not always true because sometimes 2 to the x is bigger. Sometimes it's smaller. So the green line, the y value sometimes is bigger and sometimes it's smaller. It depends if it's before 3 or after 3. And so this c value really is saying 3 here because that's where the graph intersects, the x value where it intersects. So it says 2 to the x is less than 2x plus 2. But if x is bigger than 3 here, then 2 to the x is bigger than that. So this graph, this is basically saying that c value is 3. And it's saying the graph, the green line is below the yellow line, the kind of orangish line, until it reaches some value. And then at that point, the other line is bigger. Does that kind of make sense? Any other questions? Oops. Oh, sorry, wrong PDF. Any other questions? Y'all good? Okay. If there's no more questions, I will stop the screencast. Thanks for coming. See y'all.